Big Data Analytics course. Our team name is Smart Data. My name is Ray Zhang, and my team members are Jilin Jiang and Jiali Gao. Our project is fixed to Lending Club Investor. It is the portfolio recommendation based on Lending Club data. So I will introduce our project in the 6 steps: the motivation, the data set preprocessing, default rate prediction, and self-design risk index, and portfolio optimization UI, and difficulty and future work. So for the first block, our motivation to do this final project is that the first Lending Club is the largest online loan P2P platform in United States, in the world. So many people use this platform for the investment. But the Lending Club didn't provide a portfolio recommendation for individual investors. So it is the reason that we do this project. And also our novelty is that not only predict the default rate, because most studies stop at this, we provide the investor for the portfolio recommendation. Also, we build a P2P loan risk index. A little reference about building static risk index of P2P loans. There is no time series data. Also, we provide a user interface for people to do their portfolio optimization and recommendation. The tools of our dataset and preprocessing is Spark, Python, and also Flask. Our data is downloaded from Lending Club official website. It contains over 10 years data. So the dataset is around 1.8 GB. The history data is over 100 columns and 1.7 million loans. The variable basic two parts. One part is the borrower information and loan information. The next part is the loan status information. It's also the history of the loan information. So for the data addressing part, the very beginning step is drop columns that contain more than 90% missing values. And also we cover string to float. For example, we covered gray to numbers, and also we use the variable that cannot have foresee the future value, and we drop off the variable that have strong indication. And also we drop the non-difference variable because it could significantly influence our final result. So we split our dataset to two parts. One part contains 17 columns. It contains the basic borrower information and the loan information. Another dataset contains 70 columns. It contains all the loan history information and the loan status information. So after the data selection and cleaning, we could add these filters to select data. Also, we draw the correlation matrix of the variables. We found which variable has high coefficients. In the next part, the default prediction. We use for machine learning models to do the default prediction. We do this prediction both in Python and Spark. It is a naive-Bayes model, random forest, neural network model, and logistic regression. We test the full algorithm in two datasets that we mentioned above, and it has around 80% accuracy. In the dataset contains 17 columns. It is the basic loan information and borrower information. It can use in the most case. For another set, because it contains many loans history data, so it have a higher accuracy. For the self-design risk index, we use the logistic regression that we mentioned below, and we use logistic regression to predict default probability. And we use this probability to as the risk index. We use lasso penalty to do the logistic regression. We can see the coefficient of the different variable. We range the variables of their absolute value. And then we use the logistic model to predict in the test result. It will output the 0 to 1 prediction probability. We use this probability and cover to the risk index use normal distribution. Another part is the portfolio optimization and recommendation. We focus on two parts, the return and the risk. We have multiple strategy. The clients could input the 4 different strategy in their personal investment purpose. It is the mean risk, the max Sharpe ratio, max return, low risk with same return. They can also input their risk and return they want, and we will output the portfolio that fit their investment purpose. So for the optimization, this is the optimization result. In the graph, we can see that this point is generated by the Monte Carlo simulation. The red point is max Sharpe ratio portfolio combination. The blue star is the mean risk portfolio combination. The green star is the original portfolio combination. So we can also test our portfolio part in the UI design. In our platform recommendation UI, the clients can select the risk they want, the returns, the strategies, and the diversity. So the default value will prove for the investors. If we select default and submit, we can see the portfolio recommendation result. It contains all the possible combination of the portfolio. So for the difficulties is that our dataset contains 40 more columns in 2017, and this column may contain more useful information that could change the prediction model. Also, we exclude the post-default variability. We build risk index, but we think it should consider more time series data because the risk could influence by the time series event in the history. Also, the multiple variables for the categorical feature is also difficult for us. Also, Learning Club block access screen tools algorithm. For the future work, we will improve the user interface and add more configurations. We will test the penalty parameter of logistic regression and use greedy search. And also, we compare the portfolio with a random portfolio on Learning Club platform. Thank you for you watching. Okay, this is our final result.